Hello, welcome to the Chong channel. Today we will have this video separated into two parts. We're going to look at a Regents question, August 2019, number 34, into two parts. So the first video, we're going to find the volume of the triangular prism. And in the second video, we're going to find the volume of the rectangular prism. Alright, so let's read this problem. Our cargo trailer pictured below, so this is the cargo trailer, can be modeled by a rectangular prism and a triangular prism. Inside the trailer, the rectangular prism measures 6 feet wide and 10 feet long. The walls that form the triangular prism each measure 4 feet wide inside the trailer. The diagram below is of the floor, so that means it's on the bottom of this trailer here. That's what this is, showing the inside measurements of the trailer. If the inside of the trailer is 6.5, inside height of the trailer is 6.5 feet. So that means the distance between these two bases is 6.5 feet. So we know that as this part here, H equals 6.5 feet. Now here it says, what is the total volume of the inside of the trailer to the nearest cubic foot? So I hope you understand there's two parts to the problem. We have to find the volume of a rectangular prism and the volume of the triangular prism. Now this is kind of hard to follow because this picture is the flat version, 2D, of the base. So then I made a little model here. So first what we're going to do is think of this as being the trailer, right? So we have the rectangular prism here and the triangular prism here. Right now what we're going to do is only focus on the triangular prism. Now one thing you have to understand, we just mentioned that the distance between the two bases, so that would be right here, is 6.5 feet. Which means the distance between the two bases here is 6.5 feet. Okay, now remember this is a triangular prism, so the base is a triangle. So first off, we want to find the volume of the triangular prism. I'm just going to abbreviate using the symbol. Remember, the volume formula for any prism is capital B, H. Capital B is the base area, and the base shape of this triangular prism is a triangle. Now, on the reference sheet on the Regents, they actually do give you the formula for the area of a triangle. Here it says A equals 1/2 BH, but I like to remember it as base times height divided by 2. It's the same thing. Okay, so now let's plug that in. The area of this base, or this triangle base, is base times height divided by 2. Now that is the base area times H. Now remember, these two H's are not the same. This is going to be the height of the triangle, so let me label that H here. And then this B is the base of the triangle. So let's go like this. This would be the base of the triangle. So if I wanted to find the area of this triangle, it would be base times height divided by 2 times this H. So let me call this curly H. This is the distance between the two bases. So let me just plug in that number right now, 6.5. Now if I go back to the picture here, I was told that the side parts here, the triangle, were 4 feet. So you know what, let me just draw this again. So here, this is the H, and this is 4 feet and 4 feet. So let me move this aside for a moment. Now I want the base. Well, the base of the triangle here is this part here. But if I look further over here, that's 6 feet. So if this is 6 feet, this is 6 feet. So the base of this whole triangle is 6 feet. So let me plug that in. So it's 6 times. Now here, unfortunately, they did not give us the height. But if you see here, 4 and 4, these two are the same. and the height and the base of a triangle are perpendicular. So that means this would be 3 and this would be 3. Now, if I were to cover this side of the triangle, we're left with a right triangle. And right now, I want to find what the height of the triangle is. So does anybody remember what formula you use in this type of situation? Did you say the Pythagorean Theorem? Absolutely correct. So we got a squared plus b squared equals c squared. C is the side opposite the right angle, which is the hypotenuse. So let's put 4 squared. The order for A and B actually doesn't matter, so let me just put h squared plus 3 squared. So now we're just solving. We have h squared plus 9 equals 16. You want to solve for h, so the opposite of plus 9 is minus 9. What you do on the left, you do to the right. So h squared equals 16 minus 9 is 7. You want to solve for h, so the opposite of a square is square root. What you do on the left, you do to the right. So now here on my calculator, I'm going to do the square root, so that's the blue button, second, x squared, and then I'm going to put 7. So here I got 2.6457. So we got h equals 2.6457. So going back to this picture, we had to go through all this to figure out what the height of the triangle base was, and it was 2.6457. Remember, when there's a lot of numbers that show up on the calculator, you have to copy the whole number and 4 numbers after the decimal. So now let me plug that into the formula. So once again, the base of the triangle is the base times height, so 2.6457 divided by 2. That's the base area times the, so going back to this picture, times the distance between the two bases. So that would be like here, and that would be 6.5. Now, so when we put this in the calculator, I have 6 times 2.6457, whatever that is. I'm going to divide that by 2, and then I get 7.9371. So the base area is 7.9371 times h, the distance between the two bases. So I'm going to times that by 6.5, and then I get 51.5911 cubic feet. We're actually not done with this regents question, but like I said, I'm going to separate this into 2 videos. First, we just found from the whole trailer, we only focused on the triangular prism portion. Okay, hope that helped. Bye-bye, scholars.